In this video, we will talk about counting problems that involve addition. So these will involve situations where we have cases. So let's look at an example, which says that a website requires passwords whose characters can be letters. So those are things A, B, C, up until Z, or digits, which are integers between 0 and 9. And the passwords are not case sensitive, which means that an uppercase letter like capital M and a lowercase letter like lowercase m are treated the same. So the question says, how many possible passwords are there that have between 6 to 8 characters, inclusive? So inclusive means, it could be 6, it could be 8. So everything between them, including those two values. Okay, so what I'm looking for is the number of passwords of length. The number of passwords of length 6 up until 8, 6 to 8. And we've seen this notation before when I draw these absolute value bars around a set. That's talking about the size of that set. How many elements are there in that set? In this case, how many passwords are there of length 6 to 8? Well, there's 3 different cases. Either it's going to have a length of 6 or a length of 7 or a length of 8. So based on this, there's 3 cases. Length could be length equals 6 or equals 7 or it equals 8. So if I count the number of passwords with each of those lengths, I'm just going to add those up. So I can find the number of passwords of length 6, count the number of those, and then the number of passwords of length 7, count the number of those, and then find the number of passwords of length 8, count the number of those, and then add all of those together. If I add all those together, I'm going to have the number of passwords that have any length between 6 up until 8. So how many passwords are there that have length 6? Well, so I'm going to be thinking about passwords that have 6 characters. And for each character, I could be inserting a letter. So there's 26 choices for a letter, or a digit, and there's 10 choices for those. So that means there's 36 choices for each character. Here. Okay, so for passwords of length 6, I'm going to be taking 36 choices here times 36 choices here times 36 choices here and multiplying those together. So that's going to give me 36 to the 6th power, because I'll have to be multiplying 36 times itself 6 times. Passwords of length 7, that'll be 36 to the 7th power. And passwords of length 8, that would be 36 to the 8th power. And we are going to be adding each of these together. And doing that gives me my final answer. That gives me how many passwords there are of length between 6 to 8 inclusive. Okay, so I want to end by just a final observation about problems like this. So in general, when we are counting the number of elements in a union, so remember, a union means like A or B or C. If I have a union and these sets A, B, and C are pairwise disjoint, which means no 2 of them overlap. So that means if I were to draw the Venn diagram of this, the circles for A, B, and C have no overlap at all among the circles. And that's what's happening here, because if a password has length 6 versus length 7 versus length 8, well, there's no overlap in those 3 cases. Like, it can't have length 6 and length 7 at the same time. There's no overlap there. So it turns out if there's no overlap and I'm counting the number of things in the union, well, it's just going to equal the number of things in the first set plus the number of things in the second set plus the number of things in the third set. And that's what we saw here. So when we have completely disjoint, I'm going to fill in the blank, cases in a counting problem, then we end up adding them together to get our final answer. In a later video in this section, we'll talk about, well, how does this change when there is overlap in our 2 sets? So it gets slightly more complicated there.